Hello viewers, welcome to UN College Digital class. In this class, I am going to discuss about issues regarding design of code generator in compiler designing class. In the previous classes of compiler designing, I have discussed about the different phases of compilation. In this class, I am going to discuss in detail about the code generation, which is the last phase or the final phase of compilation. Let's start. Code generator converts the intermediate representation of source code into a form that can be readily executed by the machine. A code generator is expected to generate the correct code. Designing of code generator should be done in such a way so that it can be easily implemented, tested and maintained. If we will discuss the different jobs which are associated with code generation or what is the task performed by the code generator, then that can be mentioned in this way. Okay. First of all, we know that there must be one input to the code generator. Which one is the input? The intermediate code is the input to the code generator. Okay. Then it is the responsibility of the code generator on the basis of target machine, on the basis of machine in which the code is going to be executed. Accordingly, that the target program will be generated, and to perform that, number of operations are performed by the code generator. What are those? Memory management, instruction selection, register allocation, and finally evaluation order. All these are the very important tasks performed by the code generator. Now I am going to discuss one by one all the issues, all the factors which are associated with code generation. Okay. The first one is the input to the code generator. It contains the intermediate representation of the source program and the information of the symbol table. Already we have discussed in the previous class what is the value, what is the important factor associated with symbol table. Okay. The source program is produced by the front end. The intermediate representation has the several choices. What are those? Postfix notation, syntax tree and the 3 address code. We assume that the front end produce low level intermediate representation, that is value of names in it can directly manipulated by the machine instruction. The code generation phase needs complete error-free intermediate code as an input requires. Okay. The target program is the output of the code generator. The output can be assembly language. It allows subprogram to be separated, compiled, or the target program may be reallocatable machine language. It makes the process of code generation easier, or it may be absolute machine language which can be placed in a fixed location in memory and can be executed immediately. Now I am going to discuss about memory management, which is very important job performed in code generation. During code generation process, the symbol table entries have to be mapped to actual P addresses and levels have to be mapped to instruction addresses. It is very much important. Mapping name in the source program to address of data is cooperating done by the front end and code generator. For example, suppose in the program you have used int A, B, C. A, B, C are the name which are given by you as a programmer. Okay, but during the code generation, the system has to understand that what is the address of A and what is the address of B and what is the address of C. It means that the addresses must be mapped with the name, that is A, B, C. It is one important job, the mapping, which is done during code generation. Local variables are stack allocation in the activation record, while global variables in static area. Global variables, we know that which can be accessed by number of sub procedures or which are alive throughout the program execution. Those are available in the static area, whereas local variables are stack allocated. Instruction selection. Nature of instruction set of the target machine should be complete and uniform, because it is very much important. It is the final phase of compilation, and after that execution will be performed on the code generated by the code generator, and for that reason instruction selection is very important and which must be considered. When we consider the efficiency of target machine, then the instruction speed and the machine items are important factors. The quality of generated code can be determined by its speed and size, obviously. Now here I have used an example. The three address code is A equal to B plus C, D equal to A plus C. Okay, suppose this is the problem. Now, inefficient assembly code, suppose we will convert, or the code generator is will convert the three address code instruction into machine code. In this way, here you can see that move BR0. Let me use the pen so that I can clearly explain it. Here you can see that move BR0. Okay, this one is used to store B value. Here we have used how many variables? One is A, another one is B, then C, then D, then E. 5 variables. Okay. First of all, we are using B variable and we are storing B variable with R0. Then we are using C variable and we are storing we are just adding C value to R0. Okay, it means that here what we have done, we have just added B plus C and we have stored the result at R0. Then we are moving R0 to A. Okay, it means that after this statement we have executed this one. Okay, A equal to B plus C. Then move A R0. It means that again we are using R0 will contain A. Then add E R0. It means that E plus R0. R0 is containing A value and we are adding E to R0. It means that we are just using this statement, not the whole one. Then finally we are using these statements, and in this way we have calculated this one, in this way, but this one is inefficient. Why? We will discuss now. Here you can see that when we are using the first statement, okay, in order to perform the first statement A equal to B plus C, these three statements are used. Move B R0, add C R0, then move R0 comma A. Okay, only these three statements are efficiently can handle the statement A equal to B plus C. But here we have used the statement move A comma R0. It means that R0 contains A value which is not required because here A contains R0 value. It means that R0 value and A value are both same. And for that reason, if we will directly use the statement add E equal to R0, and then finally we will use the statement move R0 equal comma D, then we can get the same output. So if we will just eliminate or discard this particular instruction here, then this can be more efficient one in comparison to particular this type of instruction set, and for that reason I have told that this one is inefficient assembly code. Okay, I hope you have got some basic idea on that concept. Now we can I am going to discuss about the register allocation. We know that register can be accessed faster than memory. Okay, the instruction involving operands in registers are shorter and faster than those involving in memory operand. Already if you are acquainted with C programming, then you may know that the int variable particularly can be declared as register variables, and if any variable is declared as register variables, then the variable is much more faster in comparison to other variable which reside in the main memory. Because obviously the register is faster, and for that reason we can access data from register in a very faster speed. But the limitation of register is that it is shorter, okay, and also expensive to be used. Now we will discuss about some sub problems which may arise when we use register. What are those? Register allocation. In register allocation, we select the set of variables that will reside in register. It is a very tough job exactly. Suppose you are using 10 or 15 or 20 variables. At that time, it is very difficult for the compiler to decide which variables will be allocated in register at which time. Then register assignment. In register assignment, we pick the register that contains variable. Certain machine requires even odd pairs of registers for some operands and result. Okay. Now I am going to give one example so that you will be clear. Now there is its division instruction of the form dxy, where x is the dividend even register in even odd register pair, y is the divisor. Even register used to hold the remainder, odd register is used to hold the quotient. Okay, in this way we have to very careful during the register allocation, assignment, etc. Now I am going to discuss about evaluation order. The efficiency of the target code can be affected by the order in which the computation are performed. Some computation orders need fewer registers to hold results of intermediate than others. Approaches to code generation issues. Code generator must always generate the correct code. It is essential because of the number of special cases that a code generator might face. Some of the design goals of code generator are correct code, easily maintainable, testable, efficient, etc. Here I have used one example of instruction selection so that you will be very clear on the concept. Let the instruction R P equal to Q plus R and S equal to P plus T. Here the assembly coding are move Q R0, add R comma R0, move R0 comma P, move P comma R0, add T comma R0, move R0 comma S. Here you can see that for the instruction P equal to Q plus R, the instructions are move Q R0, add R R0, move R0 comma P, move P comma R0. All these are used for the statement. Okay. Actually, the first statement, second statement, third statements all are used for addition. This one P equal to Q plus R0, and for the next statement S equal to P plus T, here we have used P plus T. Here we have used this statement. Okay, move P comma R0, RT comma R0, move R0 comma S. Here the problem is that one particular statement, the fourth statement, is redundant. If we will eliminate this one, then our code will be efficient one. So instruction selection is very much important in code generation. By using it, we should understand that we should take care of which instruction we will select from all the converted instruction. Okay, in this way instruction selection plays important role. I hope that you have got the clear basic concept on this point. Another most important factor associated with the issues in code generator: as the number of variables increases, the optimal assignment of registers to variables becomes difficult. Mathematically, this problem becomes NP complete problem. Here I have used one diagram to show you the exact location of code generator. Here you can see that the when you have entered into the source program, the first one is lexical analysis, then number of operations are performed like lexical analysis, syntax analysis, semantic analysis, and then intermediate code is generated. Then code optimization techniques are used on intermediate code. Then the optimized intermediate code is passed to the code generator. Actually, in this session, we have discussed about the issues and the factor associated with code generator, and after the code generator working the job properly, the target program is generated. And here also you can see that the job of symbol table, how much it is important. It is associated with the other pages along with the code generation also. Now I am just going to summarize the today's class, the issues associated with code generation. The code generation can be considered as the final phase of compilation. The post-code generation optimization process can be applied on the code, but that can be seen as a part of the code generation phase itself. The code generated by the compiler is an object code of some lower level programming language, for example, assembly language. We have seen that the source code written in higher level language is transformed into a lower level language that results in lower level object code, which should have some properties. Okay, what are those? The first one is it should carry the exact meaning of the source code, and the second property is it should be efficient in terms of CPU uses and memory management. Here I want to discuss about one important factor associated with code generation. If the value of a name is found at more than one place like register, cache or memory, then the register's value will be preferred over the cache and main memory. Likewise, cache value will be more preferred in comparison to main memory. Main memory is rarely given any preference. Before concluding the class, just I am giving one more example so that you will be very clear. Here I have used some statements. The first statement is t equal to a into b, and the code which is the target code generated for particularly this statement, those are load a comma r0. It means that a value will be loaded into the register. Then multiplication, for multiplication mult mult b comma r0. It means that r0 equal to r0 into b. R0 contains a, and for that reason a into b will be implemented by using this particular code. Then the next one is u equal to a plus c, and for that the code generated are load a comma r1. Here I have used the r1 register, and the a value will be loaded to r1 register. Then add c comma r1. It means that a plus c will be implemented by using these two statements. Then the next one is v equal to t minus u. Here sub r1 comma r0. The first one a into b is already in the first statement, that is the register, that is r0. Then the next result, that is a plus c, is with r1. So if we will subtract r1 comma r0, then we will get the third output. Okay. Then the last statement is w equal to v into u, and for that particular statement I have used the statement I have used the code, that is mult r1 comma r0. And finally we need our final output or final result with w, and for that reason I have used the statement or target code, that is load r0 comma w. In this class, I have discussed about code generation, issues associated with code generation. In the next class, I will discuss about code generation algorithm along with register, descriptor, allocator, etc. I hope you have got some basic clear concept in this class, but still if you have any doubt, then please write to me in the comment box so that I can clear your doubt. Thank you so much for watching. Have a great time.